Dear students and participants of the course on railway engineering, we are back with the discussion on fastenings. We will be discussing about the rail to sleeper fastenings, the fastenings which are other than the elastic fastenings which we have discussed in the previous lecture. In that lecture we talked about the requirements of the elastic fastenings, and then specifically we talked about rubber pads, we talked about the nylon cord rubber pads, we also talked about the metal liners, and then towards the end we have discussed about the glass filled liners also. Now in today's lecture we will be going ahead with the few of the elastic fastenings which can be used between the rails and the sleepers, and they are defined as the elastic rail clips. And then after that we will be talking about the fastenings which are specific to the different type of the sleepers, the CI sleepers, the steel sleepers and the wooden sleepers. So let us start with the elastic clips. Now these elastic rail clips, if you see on the right hand side, there is a rail section and a sleeper at the bottom, and they have been jointed together by this type of a clip. So this is one elastic rail clip. There are different types of elastic rail clips which are available. They are defined as ERC round. ERC is elastic rail clip. So here we can see in short. So it can be round, it can be flat, it can be defined by a name MK2 or MK3. There is MK5 or there is an ERCJ also. So those which have been in use, only those being talked here. Now if you see in the photograph, you can see that these clips, they have been used at the top of the sleeper so as to keep the foot of the rail in position. Now these type of elastic rail clips, they are suitable for the modern tracks. As we discussed about the various requirements, they can withstand the vibrations which can get induced in the track because of the lateral and longitudinal movement of the wheel and flanges. They also sustain the static and dynamic cyclic stresses which will be there. So cyclic stresses means it appears, goes, that is the way it is happening. So any static or any dynamic effect of that, if it is there, so that can also be sustained. They resist the creep and torsion. So this was one of the another requirement. We said that they should be able to resist the longitudinal movement. They should be able to resist lateral forces which are there. So if they are resisting, it means the rails will be kept in position. They should resist the lateral forces, maintaining the gauge, and they should have the long service life as well as the low maintenance cost, which is again a requirement. So the elastic rail clips, they are fulfilling those requirements. Now what are the properties of these ERCs? Let us look at first of all that. So grain size, that is 6 or finer. This we did talk about in the glass filled liners. Then the hardness, it is between 375 to 415 if you are talking about a scale HBW. So Brenner hardness W scale is there, Wolfram scale is there, 380 to 435 HV or 40 to 44 HRC. So depending on which particular type of test is being conducted, the values have been defined here. The tolerance for the diameter is plus 1% and minus 0.8%. So this is the diameter we are talking. Depth of decarbonization, not more than d by 100 or 0.25 mm, whichever is less. So if the diameter here which we have talked as d, so d by 100 is the value which we are taking here. The surface, it should be free of any distortions, any type of twist which may happen, the kinks, and it should be straight. So whatever surface is being used, there should not be any problems with respect to that surface. The way it needs to be manufactured for the given design, it should be there. Talking about the ERC round toe. Now this ERC round toe, it has a diameter of 20.64 mm and the weight of the clip is 1 kg the toe deflection is 11.4 mm and the toe load is ranging between 645 to 800 kg. That means this clip is going to put a pressure here of 645 to 800 kg. So, that is a pressure being placed here at this point. And because of that, if there is any deflection which is getting induced, shall be within 11.4 mm. And when you use these particular clips, when the construction is being done, you will find that they are around 1 kg in weight. The another one is a flat toe. Now, in the case of flat toe, the diameter is almost same, as we see that it is 20.64 there. The weight of clip is also 1 kg. The toe deflection is also same. The toe load is also same. So, there is no difference in the round and the flat toe. The only difference which is coming is in terms of the contact area. In the case of contact area, on the major axis it is 28 mm minimum, in the case of minor axis it is 9.5 mm minimum. So, whatever the contact area is getting created based on the way it is being put on the rail. So, that contact area is being taught. The third one which is used is MK3 flat toe. So, you can see here MK3 flat toes being shown in the photographs. Now, these MK3 flat toes, they are universal in nature. That means they can be used on 52 kg and 60 kg per meter rail sections. Diameter is same, but the weight of the clip is a bit lesser. It is 910 grams instead of 1000 grams in the previous cases. Toe deflection is also changed, and instead of 11.4, this is 13.5 mm. Toe load, we can go to a higher value here, 850 to 1100 kg is the toe load. So, that is the load which one particular clip is going to put. And the contact of the surface of the flat toe clips, that is 28 mm and 9.5 mm minimum in the case of major axis and minor axis respectively. MK2 flat toe, the diameter is 18 mm. So, change is here. The weight is also lesser, 0.6 kg only. Deflection is more or less equivalent with respect to the previous two cases which we talked about as a round and the flat toe. Toe load is again reasonably higher than those initial cases, and the contact of the surface of the flat toe clip which is being shown on the right hand side. So, here some values are different, it is 20 mm and 8 mm minimum. If you see in the previous case it was 28 and 9.5 mm and it was further different in the previous case. MK5, that is another one where the diameter is either 23 mm or 20.64 mm for the central leg. So, there are two diameters which can be there. Weight of the clip a bit heavy, 1.14 kg or 1.08 kg in the case of clip. Toe deflection a bit more, 13.5, and the load, toe load you can see is the highest one which is coming here. Before we talked about up to 1000 kg. So, here what we are talking is 1200 to 1500. The flat surface contact area is more or less similar of one of the other type of the ERC clip which we have discussed previously. So, you can see here how these looks like. This is in the case of an elevation. So, when it is being placed, this is how you will find it. This is from the side and this is from the top. So, if you are looking at the top, then this is how it will be seen. There is an ERCJ. In the case of ERCJ, the diameter is 20.64, the weight of the clip is a bit lower than 1 kg. Deflection is low, very low in this particular case, 8.5 mm only. And at the same time, the toe load which it is exerting is also lower in case of all of the type of the clips which we have discussed. So, it is 650 kg minimum. One another thing which being discussed here separately, previously we were talking about the contact length in the case of major axis, minor axis or even we were not talking about that initially. Here we are talking about the bearing length, and this bearing length is 15 to 20 mm. So, that is the way it looks like. So, if you see here, so it is from the elevation, from the side, from the top, this elastic rail clip J can be looked in this form. There is another one which is IRN 202. This is a Indian Railways design being numbered as 202. It is used on 2-block reinforced concrete sleepers. 2-block reinforced concrete sleepers means that we have a block here and there is another block at this side. So, a rail is being seated at the top of this and they have been connected by a tie. So, this is a 2-block reinforced concrete sleeper. Here the diameter is 18 mm, the toe deflection is 18.5, so it is a bit higher. The toe load is 1000 kg minimum, hardness it should range between 375 and 415 BHN, that is a Brenner hardness number. Creep resistance is 50% of the total toe load. So, the total toe load here is 1000 kg. So, 500 kg or 0.5 tons is the creep resistance which it will be offering. Hold in position by bolt and clamp arrangement, and problem here is that it is not a fit and forget type. It has been found that it is costlier and heavier too. So, these are the demerits of this particular clip which has been observed. There is another type of elastic fastenings which is known as HM elastic fastenings, or Herbert Meyer as a name for this type of fastenings. So, it has 4 coach screws and these are tightened against the plastic dowels of the PRC sleeper. So, we have the screws and they have been inserted. Then each clip it weighs only 0.4 to 5 kg. The toe load is still high as 1100 kgs. Toe deflection is again in between a medium range as compared to the previous types of the ERCs which we have discussed is 13.5. Creep resistance per sleeper is 3000 kgs. So, it is a good value, 3 tons of resistance being offered, and that is useful when we talk about LWRs and the resisting lengths there because of the forces which are coming due to the temperature variations. Then creep resistance is higher than the combined resistance which is being offered by the sleeper and the ballast. Then grooved rubber pads, they are used below the sleeper. So, you can see here there is a grooved rubber pad. So, this is going to be having grooves at intervals, and we did talk about it, that was 11 mm center to center. Then thin insulated shim is used between the angle plate and the concrete sleeper. So, this is one additional thing being used. Gauge is maintained using an angle guide plate. So, advantages of using this HML fastenings is it has higher toe load, it has better creep and torsional resistance, it has better dampening of the vibrations, and it also helps in the insulation. There is a quick tightening and loosening of these type of fastenings because of these screws which has been used to put them into position. They are more pilfer proof. They are fixed in the concrete sleepers before the concrete sleepers are dispatched from the plant. So, pre-fitting is already done. Now, let us come to the fastenings which are required for the very specific type of sleepers. So, first of all we are talking about the CI sleepers or the cast iron sleepers. Now, in the case of CI or cast iron sleepers, one type of fastenings which is used is MS cotter. You can see here on the photograph the way the MS cotter looks like. So, it is a metal sheet which is having grooving at the center like this, and there are different types of these cotters which are available. They are central split cotter, side split cotter, solid and split center cotter, and the band plate cotter. So, 4 different types are there. So, if you see here in the case, the first one at the bottom is the band plate cotter, the another one is the solid and split cotter, and then we have a central split cotter, and this is a split side split cotter. So, different type of cotters are there and their different sizes, the dimensions they have been defined. You can see that this tapering which is being done here, this is at 1 in 8. So, 1 in 8 taper is being provided here in general. The length of the cotter is 152 mm, the weight is 0.35 kg, and the splitted length is 112 mm. That means, if you are talking about this total length which is 152, we are talking about the splitted one here, and this splitted one is 112. So, that is the difference. Now, the another thing which is used is a MS tie bar for the CI sleepers. Now, here in the diagram which is being given on the right hand side, you can see that there is a rail at the top and there is a CI sleeper being provided at the bottom. So, a chair is there in which the rail is being seated. Here the tie bar, MS tie bar is being provided. So, this is the MS tie bar which is going towards the other side. So, one pot is being provided on this side, another pot is provided here. So, this tie bar is going to be in this form. So, it is connecting both of these. So, it is a sort of a 2 block concrete sleeper type of a condition. So, it used to holding the 2 plates of the CST9 sleepers together. Its length is 2720 mm for the broad gauge, and the section of tie bar is 50 mm by 30 mm. So, 2720, as you can see, this is the length being shown, and then this is 50 mm, and then there is a 13 mm on that side. The weight of this one MS tie bar is 18.62 kgs. So, various types of dimensions which are there along with the tolerances, they have been shown in this photograph. In the case of steel sleepers, the one thing which is used is a loose jaw. So, you can see here this is a loose jaw which has a grooving here in this place, and then the rail is going to be seated here, and then finally there will be some device with the help of which the tightening will be done. So, it is initially pressed up lugs which were used, which caused damage, which caused cracking as well as deformation to the trough sleepers, the trough steel sleepers which were there. Now, these spring steel loose jaws, because of their shape, the way they have been used on the sleepers, that is the steel sleepers, they can easily replaced. So, that is one of the advantage of using these. The weight of each of the loose jaw, this is 0.288 kg approximately, so roughly 0.3 kgs. The another thing which is used in the case of steel sleepers is a two-way key. Now, this two-way key, if you see here from the side, from the top, that has been shown. So, it is a trapezoidal section being provided. So, this trapezoidal section, this is to be inserted in the steel sleeper so as to keep the jaws in position. So, here it is a universal application, can be used with the trough sleepers, bot sleepers, CST9 sleepers. So, different type of sleepers which have been used on Indian Railways, for slowly now we are coming to the concrete sleepers. So, these can be used there, but there are still locations where the concrete sleepers may not be good. In those cases, we are using these other sleepers. A two-way taper is provided at both ends. So, a two-way taper is going to be provided in this form. This key can be driven in both the directions, whatever the way you want to drive. If you want to drive the smaller size first, or you want to drive the upper one first. So, whatever way it can be done. The length is 190 mm for the broad gauge 52 kg per meter rail section as well as 90 R rail section. The taper is 1 in 32. So, with respect to the size, so this tapering is going as 1 in 32. There is a gauge adjustment of up to plus minus 3 mm, and this can be done based on the way this key is being driven. So, you are driving this key. So, up to what particular level you have driven, on the basis of that this particular tolerance can be adjusted. So, if it is not getting adjusted at this point, maybe it can get adjusted here or it can adjust it here. So, depending on that it is being inserted. Now, when we are driving these keys, that is how what we just talked about. There are different type of sleepers, different type of conditions wherein it has been defined at how it can be done. See, in the case of a single line CST9 sleeper, now this driving of the key, it has to be in the same direction on all the sleepers. So, continuously you have a rail section. So, this rail section is being placed at the top of n number of sleepers, and there if we are using this keys, two-way keys, so they are going to be driven in the same direction. When we say same direction, it means if we are taking this smaller dimension first and going inside, then in each particular case it is going to be done the same way. In the case of single line steel trough sleepers, the outer keys in one direction and the inner keys in the opposite direction on alternate sleepers. So, it is going to be inserted to hold the rail. So, when we are holding the rail, so one is going to be used on this side, another is going to be used on the other side. So, one is, say, if this is outer, then this one will be inner, depending on if the gauge is on this side. So, if that is happening, in that case it says, in the case of outer keys one directions, inner keys in the opposite direction on alternate sleepers one by one. So, if it is 1, 2, 3 and so to n. Single line wooden sleepers, if we have the wooden sleepers in which we are using these two-way keys with single key in the same direction and double key same as a steel trough sleeper. So, the way we have talked here, it has to be done on an alternate sleeper, it is going to be in opposite direction with respect to inner and outer key. Double line CST9, 75% in the direction of traffic and 25% in the opposite direction. So, that means when the traffic is moving, say, in this direction, so 75% are going to be inserted on this side, whereas 25% is going to be inserted on the other side. Double line CST sleepers, all in one direction on one sleeper and opposite direction on the next sleeper in the breathing length of the LWR track. That is the length of the track which is moving. We did talk about it on the basis of the thermal stresses, forces which are going to be induced, some of the portion of the LWR will move. So, in that particular area we are talking opposite direction next sleeper in the case of the breathing lengths. Double line ST sleepers, same as the double line CST sleepers, that is the one which we talked here. But in the case of the breathing length on the LWR tracks, two inner keys are in one direction and other keys are in opposite direction. Now, number of keys which are going to be inserted here, based on that, the two keys in one direction and the third key in the opposite direction. Direction of the key is reversed in alternate sleeper, that is an additional thing needs to be done. So, if you go back, so if you are talking about these alternate one, that is what we are talking. So, in that case the directions are reversed. The another type of a fastening which is used is a coated fish plate. Now, this coated fish plate, when we say, it is basically being used at the insulated joints. So, it can be a rubber coated or it can be epoxy coated. The rubber coated has been in use, but because of its own properties, it has been observed that it gets abraded early or it gets damaged because of the loads which are there, and because of that reason there was a low service life. So, now what we are using is an epoxy coated fish plate. and these are being used at those locations where the insulation of the joints needs to be done on the track. One another thing which is being used on the steel sleepers is a Mota Singh liner. Now this name Mota Singh, he was the employee of the Indian Railways, and when he found that there are problems which has been observed in terms of the elongation of the holes in the through sleepers, and there is a lot of wear and tear which is being caused due to the moving loads. The person devised and looked at that particular problem and devised a design, and that design has been given a name by his name as Mota Singh liner. This Mota Singh liner, this overcomes the problems of the elongation of the holes and has been used on Indian Railways. So it is being shown here how this is, what are the dimensions, what are the shape of that Mota Singh liner is there. Talking about the wooden sleepers. Now in the case of wooden sleepers, there are different type of spikes which can be used. So there can spikes and screws. So first one which we are talking here is a dog spike. So if you look at on the diagram which is being shown on the right hand side, at the top here, if you see, it gives you a feeling that that's a face of a dog, and that's the reason the name is being given as a dog spike. Now dimensions are being shown, that what should be the straight section, then the taper, what is the depth here, again a taper, and then a curved section being provided, and finally at the bottom again the tapered section has been provided. From this side, if you are looking, that's a elevation which is there, and if you are talking about the plan, then the bigger size and the smaller size, on the basis of that, this is how it looks like. So these are the lugs which are provided on the spike head for extraction. For fixing dog spikes, holes are bored with augers. The hole diameter is 16 mm on the hardwood which is untreated sleeper, and 14 mm on a softwood which is a treated sleeper here. So the treatment has to be done for those wooden sleepers, and these are the standardized practices which has been used on Indian Railways whenever the wooden sleepers have been used. Now spikes, they may get pull up due to the wave action under the traffic load. So whenever this wave action is there and the train is moving, so there is a possibility that at particular point this spike, it will come out a bit. So that loosening is a possibility, and when these spikes get loose, they are pulled out and a wooden plug is placed in that hole. Another hole is bored to place the spike again, because now once it has got loosened at that particular location, it will not remain there even if you try to do it further. The number of spikes on a straight track, 2, 1 on either side. On the case of curved track, there are 3, 2 on the outer side and 1 on the inner side. In the case of joint sleepers or bridges, there are 4, 2 outside and 2 inside. So these are the numbers which are required to be used when you are using the dog spikes. Now section of the dog spike is 16 mm square. So based on the diameter which is there, so that section which we are talking here. The length of the dog spikes, if it's a broad gauge points and crossings, it is 160 mm plus minus 3 mm. If it is a canted bearing plate, it is 135 mm plus minus 3 mm, and if it's a track without the bearing plate, then it is 120 mm plus minus 3 mm. So the tolerance remains the same, but the size is reducing with respect to the different locations or different conditions in which these are being used. Another type of spike is a round spike. You can see here this is totally round, which is being provided with an elongated head at the top. So this is one type of system being used. These are used with anti-creep bearing plates. They have been found to be better performing there. They are also used to fix assemblies of switches on the sleepers. So that's another location where the round spikes can be used along with the wooden sleepers. The section of the spike which is there here, this is a round spike actually. So just a correction can be done by you. It is a 18 mm diameter here, and the length depends on the purpose for which it is being used, but now they have been not in use. The another one is a screw spike. You can see the way the screws have been created here. So, these are preferred about the dog spikes. They are used on high speed or the main or the trunk roads. They are also used on the bridges and the platform lines where there is always a possibility of more pressure coming in terms of the braking and acceleration or the starting of the trains or the control of the speeds being done at that particular location. The pull out resistance is double of that of dog spike. So, this is also an important aspect with respect to the property of using the screw spikes. They helps in increasing the lifespan of the sleepers because they remains in position, do the function properly for a longer period of time. The length varies to suit the type of the sleeper with or without a bearing plate for different gauges. It is provided with greater head width and the sloping surface for better hold of rail with sleeper. So, that is what you can see here. The head width is a bit higher, but the sloping surfaces are being provided so that when it gets inserted, it remains in a better hold, and that better hold is also going to be there because of the screw that threads which have been made on this screw. Now, in this screw spikes, there can be two types of screws. One is defined as a plate screw, another is defined as a rail screw. So, plate screws, they have replaced the round spikes used with anti-creep bearing plates, and rail screws, they directly fasten the rail and the sleeper with or without the bearing plates. So, here the rail screw is being shown in this diagram, and certain dimensions of this particular rail screw, say this value of B, which is between the elongated head and the constant diameter of the screw after which the threads are starting. So, that is B, and then there is a C distance, there is an E distance or F distance, H distance, which is the thickness of at this point, the length which is there from this thickness to the end of the screw. So, all of these values of A, B, C, D to K, they have been provided with for two cases. One is when it is being used without bearing plate. So, BP is bearing plate, and another one is when it is being used with the bearing plate. Similarly, in the case of the screw spikes, there the dimensions again they have been given as being denoted by A, B, C to K. They have been used with crossing timbers or with the CI anti-creep bearing plates. Again, in that case, we find that the dimensions are being shown clearly. So, whatever the values are there for different dimensions like A, B, C, D being shown here in this diagram, you can use that. The another thing which is used with the wooden sleeper is a fang bolts. They are used under the switches for fastening the slide chair. So, we have a slide chair here, and so as to keep the slide chair in position, these fang bolts are used. They are used at locations where the gauge is to be preserved. Now, we were talking about the bearing plates. Now, this bearing plate, there can be a simple bearing plate which is of same thickness, or there can be a canted bearing plate where the thickness is different. So, you have a cant of 1 in 20, and when you provide this cant of 1 in 20, the rail gets tilted, and when the rail gets tilted, then that is how we are working with the coning of the wheels. So, the first one which we are talking here is a mild steel canted bearing plate. So, here you can see that the slope has been given in this case. This is a 1 in 20 slope, and on that particular slope this rail is being seated. So, there is a foot of the rail which is being seated at top of it, and so that it is not moving this way or that way. So, there is a projection being provided here, and then it has to be kept in location also. So, it is being used in the joints and the curves. Cant of 1 in 20 is provided. The size is 260 by 220 by 16 for 52 kg as well as for 90 R rail section. So, here in this diagram, if you can see, there are different things being shown. Say the A value is being defined here, which is the length of the bearing plate here, which is 260. Now, this bearing plate is going to be provided in this form at the top of the sleeper. So, that is the another direction which will be there, B, which will be 220, and likewise the rest of the values have been defined here. Now, there is a flat MS bearing plate. This flat MS bearing plate is used at the points and crossings in the lead portion of a turnout. There is no cant provided, for the name itself it comes out. The 1 in 20 is not being provided here. The size is 260 by 220 by 20 mm for 52 kg and 90 R rail sections, and the distance between the holes which are being made in this bearing plate, they are at 120 mm. So, we can see here this is a MS bearing plate being provided, and this MS bearing plate, then various dimensions they are being given here. Now, CI anti-creep bearing plate, it is used at the locations where the rail is likely to develop the creep, and here again the cant of 1 in 20 is being given. So, this is a canted this CI anti-creep bearing plate being shown. It is fixed using the round spikes. The size again is bit bigger, 285 by 205. So, this is lesser, the width is lesser, but the length is more, and is being used on the broad gauge track. There can be for meter gauge, but we are being emphasizing on the broad gauge only. So, here for 52 or 90 R rail sections, the values have been defined, and this value which is being defined here, this is for canted bearing plate, and this canted bearing plate is shown here. Now, let us talk about the material, this material requirement of a track. Now, depending on that what are the type of fastenings which are going to be there, this material requirement will be there. So, here we are talking, say if you have to do this material requirement, usually they are done for per kilometer length, and when we say that we are doing it for per kilometer length, then there will be number of rail sections which will be used, will be connected. So, depending on that, if we are going to work with the fish plated joints or so on, so we will have number of things being provided here, but if it is a welded one, then the fish plates will not be there. So, it will reduce in number. So, here when you are talking about these things, so it is first of all the rails needs to be seen, that how many number of rails are required to be used. We are talking about say 13 meters long panels of a rail section which is jointed by fish plates and fish bolts. So, in 1 kilometer if we are looking at, so this is 1 kilometer length, how many such panels will be there? The sleepers they are going to be decided by a sleeper density. The sleeper density, this can be defined as per rail or can be defined as per kilometer length. So, we have looked at this per kilometer length as like 1660 or 1540 or 1310 sleepers per kilometer. So, based on that, then we will be knowing that how many sleepers needs to be provided. Fish plates. Now, when we talk about a fish plate, the fish plate will be provided at this type of a joint between the two rail sections. So, one is provided on this side, one will be on the back side. So, there are going to be 2 per rail per joint. Fish bolts. The fish bolts we have discussed previously that in each of this fish plate there are going to be 4 fish bolts, 2 on this rail and 2 on the other rail. So, the 4 per rail will be the way we are going to calculate them. So, as soon as you have the number of rails, so multiplied by 4 you will get those numbers. The bearing plates. The bearing plate is, that means you have a sleeper and the top of that the rail is being seated. So, the bearing plate is here at this point. So, that means now the 2 per sleeper are required. So, as soon as you have the number of sleepers known to you, multiplied by that will give you the number of bearing plates which needs to be provided. Spikes, dog spikes, they are 4 to 6 per sleeper on a straight track and 6 to 8 per sleeper on a curved track. So, depending on that we can again calculate how many numbers are required because we know the number of sleepers. So, this is all about the various different types of fastenings which can be used so as to connect the rail with the sleepers. What we have discussed is the first of all the elastic rail clips, and within the elastic rail clips there were different type of rail clips which were discussed. Then finally, we started discussing about the fastenings which are required to fasten a specific type of sleeper, say the CI sleeper, steel sleeper or the wooden sleeper, their requirements, and then finally what are the number of material or the components which are required in 1 kilometer length and how to compute those particular numbers is what we have discussed. So, with this we close our discussion now. We will be meeting in the next lecture. Thank you.